Hi everybody, Ms. Z here, and in today's video we are going to learn about the atomic structure and the history of the atom. So to start with, we're going to look at a timeline of 6 historical models of the atom. Now there are many other people who contributed to the discovery and the creation of different models in our understanding of the atom. But these are 6 of the main models that we will talk about this quarter, but we will also talk about other important historical figures and scientists that also contributed to not just the discovery and models of the atom, but also of different discoveries in chemistry. So back in 400 BC, here we have Democritus. Democritus was an ancient Greek philosopher, and he was the first one to come up with this idea of an atom. Okay, he thought that atoms were tiny spheres of a material. So he thought that clay was made up of clay atoms and wood was made up of wood atoms, and that wood atoms and clay atoms had to be different from each other because they made a different material. Then it took until 1803 for the next major discovery in the historical model of the atom. So we have John Dalton. John Dalton wrote the first atomic theory that has been published and was recognized by his peers. He said in his atomic theory that all matter is made of atoms. He said that atoms are indivisible, atoms of the same element are identical, 2 or more elements can combine to make a compound, and a chemical reaction is a rearrangement of atoms. He was right on 3 out of the 5 things that he came up with. Atoms are indivisible. We know that this is not correct thanks to learning about fission and fusion. So when we have nuclear fission, our atoms can break apart. That's how we get like a hydrogen bomb or an atomic bomb. So this one is incorrect because of nuclear fission, the splitting of atoms. And the one about atoms of same element are identical, this is also incorrect thanks to isotopes. So we will get into more of that in the next coming days, but it's important to note that he was the first one to say, well, I think this is how it is. Then in 1897, J.J. Thompson made a discovery he discovered the electron. That was what he earned his credit for. And his model of the atom is called the plum pudding model. Now, we don't really eat plum pudding here in the US, but I think of it kind of like an oatmeal raisin cookie or chocolate chip cookie, where we have our electrons are kind of scattered throughout our atom. Okay, and he didn't know about anything else in there. He just discovered that within this atom, there's electrons. So he did this by looking at a cathode ray tube experiment. Old TVs were really deep. They had a cathode ray tube in there, and that cathode ray tube would send different particles down and they would kind of scatter, and then they would bend to different directions. We'll watch a video that explains it and kind of shows an animation of it, but just know that J.J. Thompson had the cathode ray tube experiment, and he was credited for discovering the electron and its negative charge. Then about 20 years later, Ernest Rutherford improved upon J.J. Thompson's model. He said, well, I've come to find out through the gold foil experiment that the atom is mostly empty space, but there's a hard sphere in the middle, which he coined as the nucleus, or the center of the atom. So he discovered the nucleus, and he discovered that the nucleus had a positive charge, which he called those positive charges protons. So he discovered protons in the nucleus, and that protons have a positive charge. 2 years later, Niels Bohr went ahead and further improved the model and looked at where the electrons actually were. He said that the electrons really orbit the nucleus. They are not just scattered around this empty space, nor are they scattered inside a nucleus or anything else. He said that these electrons orbit around the nucleus, just like in our solar system, our planets orbit around the sun. So we will refer to it as the Bohr model, but other people can refer to it as the solar system model or the planetary model, because the elements are like planets that rotate around the sun. The electrons are rotating around the nucleus. Here, he said that the rings refer to the energy levels on the periodic table, and energy levels equal our period numbers. So eventually we will go ahead and we'll be able to draw Bohr models of all of our elements. But until then, we'll refer back to this. Then in 1926, Erwin Schrödinger did a lot of math calculations. So he didn't do an experiment, like a physical experiment. He started to do some math calculations. So he used a lot of calculus. It gets really complicated really fast. But what we need to know is that he used math to calculate these probable locations of electrons around the nucleus. So he said, okay, well, they don't really orbit in rings. They don't follow a path. They kind of like hover in a certain area. And he mapped out where those areas are. So some of them hover kind of around the center. Some of them come out in these little lobes, almost like a flower. And they have certain areas where electrons like to be. But then there's also areas of our atom that electrons don't like to be. And so because they kind of hang out in these little lobes or clouds, it's called the electron cloud model. Or because they use quantum mechanics, which is something we will not talk about, but it can be called the quantum mechanical model. I took a whole class on it in college, and only chem majors take it, so you don't have to worry about it, but it's a name that might come up, and so we want to know what that is. His model, Schrödinger's model, is the one that most chemists use today in their further research and study of the atom. So now that we know a little bit of background about the atom, let's take a look at using the most current model, kind of what's the structure of the atom and what are those subatomic particles or the things that make up an atom. So on our periodic table, on our notes of the atom, we first want to look at some subatomic particles. Our subatomic particles, subatomic, sub meaning part of an atomic, the atom, so the things that make up the atom, we have protons, neutrons, and electrons. Because in chemistry we like to write things in small amount of letters, we like to prefer a symbol for a proton as P positive because a proton has a positive charge. Neutrons, we say N0 or not, and that's because neutrons are neutral, they don't have a charge. And then electrons, we say E negative, and it's a lowercase e because electrons are little. And then it's a -1, and so we have the negative sign here. Now, the actual masses of a proton, neutron, and electron are tiny. We have this times 10 to this -24 and -28. They're kind of so small, they're hard to comprehend. So what chemists have done is instead of looking at these actual masses in grams, they've created atomic mass units and said, well, we know that protons and neutrons are about the same size. And so we're going to say that they have a size of 1 atomic mass unit. And then because an electron is, a 10,000 times smaller than that, we're going to say that's basically 0. And so in atomic mass units, electrons don't have any mass. And then our protons and neutrons have mass. And this is important when we think about where the mass of an atom is. Just like we learned with the one that discovered the nucleus, which is Ernest Rutherford. He said that it's mostly empty space except for the nucleus. And that's because our nucleus is where our protons and neutrons are located. So protons and neutrons are both in the nucleus, and then electrons are outside the nucleus, which makes sense because most of our mass, or almost all of our mass of our atom, is inside our nucleus. So a few definitions for us. An atom, by definition, is the smallest particle of an element that keeps its identity in a chemical reaction. So that's the smallest thing that still is copper, or still is palladium, or still is hydrogen. When we look at the protons, a proton of hydrogen and a proton of iron look the same. You can't tell what element they came from. But an atom, you can tell what element it is. Also, atoms have no charge, and their number of protons will equal their number of electrons. So the positive parts and the negative parts are going to cancel out. Then we have some numbers associated with our atoms. An atom has a mass number, which is the amount of mass, relatively speaking, in terms of atomic mass units, that an atom has. It is equal to the number of protons plus neutrons, which makes sense because they're the things with mass. So my protons plus my neutrons equal my mass number. I also have something called an atomic number, and that atomic number is a number that's absolutely unique to an element, an atom. So it's specific to the element, and it equals our number of protons. So if something has 1 proton, it can only be hydrogen. 2 protons can only be helium. 3 can only be lithium. And that's really nice because that means, like, if I'm referring to number 4, I know that number 4 is beryllium, and I can't be confused because it's the only one that has atomic number 4. And so the number of protons is going to dictate what atom or element you have. When we write our symbols for our elements, you'll see that the first letter is capitalized, and if it has a second letter, the second letter is in lowercase form. Okay, so if I were looking at sodium, sodium is Na, so it's a capital N and a lowercase a. It wouldn't be, just a small uppercase a. That is incorrect. We can't do that, and then you also can't just make like a large lowercase n and then an a. Okay, that's also not right. We have to do it kind of the way you were taught back in kindergarten where you learned how to write your letters. That's how we're going to write our element symbols. Then what we can also add is the mass number and atomic number. So mass number is the bigger number. Usually it's going to go on top. And then atomic number is that one that we'll find on the periodic table as well. So they get put one over the other. So if we look at our periodic table, so here we have a periodic table, and it's a big sheet so that way you guys can see. And if we look at each box on our periodic table, so if I'm looking at beryllium here, I have this number at the top. This is my atomic number. So beryllium's atomic number is 4, the number at the top. Then this number underneath with this long decimal point after it, it's called the average atomic mass, but it's not the mass number. So I can't get mass numbers from the periodic tables, but I can get atomic numbers. Now the periodic table is organized by atomic numbers. So number 1, then we go straight across to helium is 2, and then we go back to lithium is 3, 4, 5, 6, 7, 8, 9, 10, and it just keeps going on and on. So we can see that if I have atomic number 10, that's neon, and 18 is argon. Okay, so what I can do is I can fill out a chart that looks at different symbols and their atomic numbers, mass numbers, and I can calculate protons, neutrons, and electrons. So if I'm given the symbol W, which is tungsten, 184 over 74, I know that this top number is my mass number. So mass number, I can write 184. My bottom number is my atomic number. So my atomic number, 74. Okay. I also know that my atomic number equals the number of protons. So my number of protons equals my atomic number. So if my atomic number is 74, my number of protons is also 74. We are only looking at atoms here, nothing else. And I know that atoms don't have a charge and their protons equals their electrons. So for this box here, my electrons are going to equal my number of protons. So if I have 74 protons, 74 electrons. And then neutrons can be kind of tricky to find out. I know that neutrons plus protons equal my mass number. So if I'm looking for my number of neutrons, neutrons are equal to my mass number minus my number of protons or the atomic number because they're the same. So here, if I have 74 protons and a mass number of 184, I'm going to plug that in my calculator so you can see. So if I have 184 as my mass number minus my number of protons, which is 74, I am told that I have 110 neutrons. Okay. Now we can also figure out, just given the atomic number, what element we have. So here I'm told I have atomic number 29. I know that goes on the bottom, so I write 29. I know that my atomic number equals my number of protons, so this is also 29. And I know that my mass number is equal to protons plus neutrons. So mass number equals protons plus neutrons. I have 29 protons and 37 neutrons. So 29 protons plus 37 neutrons is 66 for my mass number. And mass number goes on the top. Now I need to figure out what element this is. I know that I have number 29, atomic number 29. So I'm going to look on my periodic table for number 29. And number 29 is here. That's copper. So next to 66 over 29, I'm going to write capital C, lowercase u for copper. Okay. And now on to the last one. Now we're not told the symbol or the atomic number, but we know the number of protons. So my number of protons is 8, and I can then know what my atomic number is, because protons equal my atomic number. So that's also 8. Then I know my mass number. So if I know my atomic number and my mass number, I can write my symbol. Remember, it's mass number 16 over atomic number 8. I look on my periodic table for number 8. Number 8 is oxygen, so I write O for the symbol and just one letter, so O. And then I need to figure out my number of neutrons. Remember that neutrons is mass number minus my number of protons. It's my mass number 16 minus my number of protons, which is 8. 16 minus 8 is 8. Okay. So just a quick refresher on our model of the atom. So we said the model of the atom is made up of a nucleus. Inside our nucleus has all of the mass of our atom. It has our protons and our neutrons. Protons and neutrons added together equal our mass number. Around the nucleus and all of the empty space are the electrons. The electrons circle the nucleus, and our electrons have no mass. And so eventually we'll be able to draw these Bohr models for all of our elements. Remember that if you had any questions on the video, please make a spot at the end of your notes of questions you have, and then post those in the Ed Puzzle question at the end of these videos. We'll see you tomorrow.